So our new topic is differentiation, and the key with this is really knowing your rules and being able to apply them really quickly. So the key rules that we're going to be looking at are the product rule, the quotient rule, and the chain rule, and then also how to differentiate your basic functions like trig, powers of x, exponentials, and logs. So the first thing to know is that for product rule, this is when you have a function y, which is a product of two different functions. So we'll call those functions u and v. So the two things are multiplied together. The derivative, we're going to define the derivative by using, well, we can do it two ways. We can call it y dash, okay? We can also call it dy dx. And what that means is that you're differentiating the y with respect to x. That's this part here. So if I just do that in red, the d dx, that part there says differentiate y with respect to x. So that's what you're doing when you do that dy dx. So the derivative, and I'm just going to use y dash for this, is the derivative of the first function u, so u dash, and I'm just doing this in the sort of shortened form, so I'll just call it u dash instead of, I'll put the x in here as well. So u dash v. So what that means is differentiate the first function, times it by the second function, plus differentiate the second function, and I'll just move this over a bit so we've got some more room, times the first function. And the other way you can look at it sort of more simply is u dash v plus v dash u. So every time you have a dash in something, that means that you're differentiating it. So the u dash means that u is differentiated, and it's differentiated with respect to the variable that u is in terms of. So u is in terms of x. So u dash is the derivative of u with respect to x. So product rule, nice and simple, u dash v plus v dash u. Now the reason I use this one, this is actually backwards to what's in the textbook. The textbook puts this second term first, is because this links really nicely to your quotient rule. Now quotient rule is when you have two functions and one is divided by the other. Now for the quotient rule, the derivative of y is actually the same top line, so u dash v, but it's take away v dash u. And all of that is on the top of v squared, or v of x squared. So what we can do, just writing that a bit more simply, it's u dash v, take v dash u, all over v squared. So that's your quotient rule. So the reason that I like to use this form here for product, they're exactly the same, you just have to remember the different sign for quotient rule, and then v squared goes underneath. Now whatever is on the bottom here in the original function, that's what goes on the bottom squared in the derivative. Okay, so we've got the product rule, the quotient rule. The last one is the chain rule, and this is for when you have a function y, which is a function of another function. It's what we call a composite function, a function of a function. And the way that you find your derivative, dy dx, is by taking the derivative of the function u with respect to x. So this might be like sine of x squared, so the u would be the x squared. So you differentiate that u with respect to x, times, we then differentiate the y, the whole thing, with respect to u. So you might think of this as being like cos of u, then you differentiate just the cos of u. Now the reason that this works is if you look here, see that you've got a du on the top and a du on the bottom, they cancel out. So that gives you the dy dx that you want here. That's where that actually comes from. So the chain rule is du dx times dy du, or dy du times du dx. It's the same thing. So all I'm just going to do here is just put the nice form with the dy dx and just make sure, oops, that we can see all of those. So product rule, quotient rule, and that's the product rule, the quotient rule, and the chain rule. They're your three key rules that you want to know. Okay, so what we're going to do is we're just going to use each one of these rules in this next question so we know what we're doing with them. Okay, so let's have a look. The first question that we've got here, we've got differentiate each of the following with respect to x. The first one is the square root of x times sine x. You see that you've got two functions here. Those two functions are multiplied. Root x times sine x. So we know that we're going to be using the product rule here because we've got two functions that are multiplied together. Now the key thing here is to also write this in a form that's a bit easier to differentiate. So I'm going to always rewrite any surds with x as fractional powers. So the square root of x is x to the power of a half. Okay, so now what we're going to do is we're going to, and I'm just going to let this equal y, just so it's a bit easier. I'm going to use the product rule now. So what I'm going to write underneath is let u equal, it doesn't really matter which is which, but usually I just let the first thing equal u, and let v equal sine x. Now in the formula you can see we need the derivative, u dash, and we need v dash. We need to know how to differentiate x to the power of a half. When you're differentiating powers of x, the power always comes down the front. So we end up with a half x, and then we always take away 1 off the power, subtract 1. So we're going to have a half x to the negative a half, because if you take 1 away from a half, you get negative a half. And for v dash, what you need to know for the trig, and this is a really useful one, is what I like to think of as my tower of trig. When you're differentiating, sine turns into cos turns into negative sine turns into negative cos, and then when you get down to the bottom, you come all the way back around. So the derivative of negative cos is sine. So if we look over here now, we're going to differentiate sine. You can see in the tower, we go down the tower, so the derivative of sine is cos x. So now we can have our derivative, so dy dx equals, write out your function, your formula, just so you get used to it. And now actually put everything into it. So u dash is a half, x to the negative a half, and v is sine x, plus v dash, which is cos x, and u, which is x to the power of a half. Now usually, I'm just going to move this over, when you're doing these kind of things, you really should put the trig second. It's just so that if you're putting powers of x here, it doesn't look like cos of all that other stuff. So you can see that it's just cos of x, not cos of x, and x to the power of a half. So that's really all we need to do with that one. There is, I guess, another way that you could write this one, which I'll do. I'll just copy this onto the next page. And that's just rewriting just drag this guy up, the negative power. So we could actually write this as x to the negative a half is actually the root of x, but it's underneath, like that. So you'd actually have that. And again, you've got x to the power of a half here. So to finish it off, you might want to make everything look quite nice and rationalised. So we could put the root x on the top, multiply the top and the bottom by root x, like that. So we've got root x on the top, 2x underneath, sine x on the top as well, because that's not a denominator, plus root x cos x. So what you've done is you've found the derivative of the original function, which was a product rule, root x times sine x. You've used this formula here, identified what u is, what v is, differentiated them both, and then just plugged them into the formula. You could really stop here, but if you want to do a little bit of nice simplifying and rewriting, it's nice to put it in this form here. So that would be our answer here. Okay. So for the next one, I'm just going to copy the questions over so we can see them. We need to figure out what formula we're using. And you can probably guess that because you've got something on the top, something on the bottom, we're going to use quotient rule. Quotient means a fraction, so that's why it's called the quotient rule. It's the fraction rule. So again, we just let u equal. Now with the quotient rule, it's very important that v actually is what's on the bottom in order for us to use the rule. So we have to make u what's on the top, and v has to be what's underneath, which is sine x. We differentiate just like we did before, so 2x, and we differentiate v, so that would be cos x. Now, if we're differentiating x squared on sine x, and what I should really do here, I'm just going to move this over, I'm just calling this y, just so that we can write dy dx, and it just makes a bit more sense that way. So I'll just call this y. And so now for our derivative, dy dx, we have quotient rule, u dash v, take v dash u on v squared. And this time u dash is 2x, v is sine x, v dash is cos x. And what you might notice is you've got a whole cross multiply thing going on here. These two guys multiplied together, take away these two guys multiplied together. So negative x squared cosine x, and all of that is over the top of v squared, which is sine x squared. Okay, in terms of what you can do with that, there's really not particularly much you can do. You could split it up, I suppose, but really I'd leave it. You'd be introducing cot and things, I suppose, there, but that's really fine to leave it that way. So that's your quotient rule, the rule you use when you have fractions. Okay, the last one that we've got here is this question, part C. So we've got C is cos of x squared plus 1. I'll let that be y. Now you can see here that you've got a function inside here, which we could call a function of x, u is a function of x, and then we also have this part here, and that's really a function of u. If u is the part inside the bracket, this cos is really a function then of u. Okay, whenever you have something like that, it's like a function inside another function, this is where we use chain rule. Okay, so what we're going to do is we're going to let u equal the bit inside the bracket. Generally u is always the bit inside the bracket or inside the square root or inside the exponential when you're doing chain rule. Okay, and what that means is we can rewrite y now as y equals cosine of u. You see what I've done there is I've just replaced this with u. So y is now a function of u. Okay, so a function of u. And u is a function of x. Now if we look at our chain rule, what we need to do here, you can see we have du dx and dy du. They're the derivatives of u, and the reason this is du dx, the dx tells us what we differentiate with respect to. Because there's only x's in there, it makes sense we differentiate with respect to x. So this becomes 2x, the power comes down the front, and then you take 1 off the power, which then becomes a power of 1. The derivative of a constant is saying what's the slope of a constant line? Well, a constant line has no slope. It's a straight line. And it's horizontal, so there's no slope. And here we've got dy. Now, what would we differentiate this function with respect to? Looking at the variable? du, because there's a u in there. So we need to think back to differentiating cos. Let's check it out. Differentiating cos, we end up at negative sine x. So this will become negative sine, and we differentiate, but the variable is u. So negative sine of u. Okay. To finish off, we want dy dx. Now the chain rule tells us to do dy du by du dx. And the cool thing about that is that the du's effectively cancel to give you the dy dx that you want. So now all we have to do is just substitute the things we know. We know that dy du is negative sine u, and we know that du dx is 2x. So we've put them both in. Now that looks really weird because you've got a u still in there. So the key thing with these questions is at the end you want to make sure that you do a final replacement, which is to replace the u back into your answer, because it doesn't make sense to give an answer that has u in there. So our final answer would be, I'm going to just move the 2x up the front so it doesn't interfere with the sign. So we've got negative 2x, so the negative sign from the front, sine of u, and u squared is x squared plus 1. So that means that our derivative for this function, the derivative for cos of x squared plus 1, is actually negative 2x sine of x squared plus 1. And the thing you might realise or recognise here, when you're differentiating trig, and it's a nice shortcut that you can use, is differentiating trig, you differentiate this part of the trig, cos turns into negative sine. There's the negative and the sine. The derivative of the bracket comes out the front, So see there's the 2x, that's the derivative of the bracket, and the bracket itself always stays the same. So you can do that shortcut too for differentiating trig, but that's the example there of the chain rule, so a function inside a function. So the 3 rules you need to be able to work with: the product rule, when you have 2 functions multiplied together; the quotient rule, when you have a function over the top of another one, and that's our rule there; and the chain rule, when you have a function inside another function. Always identify u as the part inside the function, find u dx, then express y in terms of u, which is your substitution, and then find dy du, and all you have to do is multiply those 2 things together to find your derivative dy dx.